It's rocket science, but not as we know it. Most rockets are fueled by liquid oxygen and liquid hydrogen, volatile and expensive liquids that are difficult to handle. Here at the University of Hertfordshire, the Energy and Propulsion Technology Unit have become expert in developing hybrid motors to drive rockets. Hybrids contain nitrous oxide plus another fuel, in this case, Toffee. Ray Wilkinson, the principal lecturer and group leader, explains.
The Toffee fueled rocket is a hybrid motor, and the fuel in this case is just this stuff, which is toffee, and this is just melted sugar. And what we do is we melt the sugar, and then it's poured inside this, which is simply a cardboard sleeve to use as a mould, and allow it to set. When the nitrous oxide comes in, it hits the burning material that's already in there. The toffee inside heats up very, very quickly at about 1,000 degrees C a second, and simply evaporates off. It doesn't melt, it evaporates off. The gases then burn with the oxygen from the nitrous oxide, and they're accelerated to very high velocity as they're ejected through the nozzle, and it's that produces the thrust.
In the laboratory, they have their own rocket motor test cell. This is where the motors can be fired safely and securely, because they can generate temperatures of several thousand degrees centigrade and expel dangerous gases, so it needs to be contained.
So, firing in 3, 2, 1, fire. All we need to do now is take our rocket motor, place it inside the rocket, and fit the retainer. So this will go up to 3,000, 4,000 feet, so quite high. It's fairly slim, so it will go high. And then when it gets there, either electronics on board or a built-in timer within the motor will fire off a charge. That will then separate the rocket into two sections, and attached to this lanyard is a parachute. This will do anywhere between about 4 and 6 or 700 miles an hour in about 2 seconds.
Another way not to lose the rocket when testing out of doors is along a cable.
Okay. 5, 4, 3, 2, 1, fire.
Toffee may not become the fuel of choice for future rocket scientists, but as rockets could well replace long-distance air travel, its hydrocarbon structure points the way towards creating safer and cheaper fuel that will be much in demand later on in our century.